Hello and welcome. In this video, we're going to be looking at solving a system of equations that has one linear equation and one quadratic equation. And we're going to be looking at basically two ways to do this. So the first one that we're going to look at is solving by graphing, and then we're going to look at how to solve it algebraically. So when we are solving by graphing, this is going to work basically the same way as if we were solving, two linear equations. And that is to say that basically we're looking for the points on the graph that are shared by the two equations. So if I am focusing in on this first example here, basically the solutions to the equations are going to be the points where the line crosses through the parabola. So when I'm looking at the number of solutions, right, I notice that the two curves cross twice. So that tells me that there's going to be two solutions to this system. To say what the solutions are, I'm simply going to list the points where the two curves cross. So it looks like we have one point down here at 0, -3. And it looks like we have our second point up here at 4, 5. So those 2 points would represent the solutions for this system. For this second example, it looks like the line and the parabola only cross once. So I will only have one solution to this system. So of course that point of intersection is right there, which looks to be -2 and 5. And that's all there is for the second example. And in this third example, I notice that my parabola and my line never intersect. So that means this system has no solution. And that's really all there is to solving with graphing. We just have to be careful about reading the points correctly, and also just be aware that if the points do not intersect at nice whole number points on the graph, then you won't be able to get an accurate solution. So if that's the case, or if we don't have access to the graph, we need to know how to solve these algebraically as well. So let's say that I was given these two equations and asked to solve for the points of intersection, or just simply to solve the system. Basically, what we're doing is looking for the points where the x's and y's match. So because my equation is already written in y equals form, basically what I'm going to do is just take the two equations with x and set them equal to each other. So this is basically substituting the equations in for y to get the values of x. So I've set it up as x squared, or x plus 2 squared minus 6 equals to 4x minus 2. So from here, it's going to work like what we had done in our previous videos where we were trying to solve for the quadratic expression. So what I'm probably going to need to do is convert the left side to kind of look more like standard form, and then use either factoring or quadratic formula to solve from there. So the first thing that I'm going to do is take that x plus 2 squared and multiply it out using the box. So we're going to go ahead and fill this in. So on our top row, we're going to have x squared and 2x. On our bottom row, we're going to have another 2x, and then 2 times 2 to give 4. So my multiplication, when I simplify the inside of the box, turns out to be x squared plus 4x plus 4. So I'm going to go ahead and replace that with the parentheses in the original equation. Since I don't have any extra numbers in front of the parentheses, I can probably just get rid of those. And then from here, we're just going to simplify and combine our like terms. So the 4 minus 6 will subtract to negative 2. Of course, in order to solve a quadratic equation, we need one side of the equation to equal 0. So we can go ahead and do like a minus 4x and a plus 2 to both sides to kind of get a 0 over there. So of course, these guys cancel, and then everything over here just cancels. So I'll get a 0 down here, and then the x squared will come down over here. And so if I see x squared and I want to drop it back down to x, that tells me I need a square root on both sides. And so of course the square root of 0 just equals to 0. And so I only got one value of x, which tells me I'm only going to have one point that acts as an intersection. So to figure out the y value for that, I just take one of my equations and substitute 0 in for x. So I will take the y equals 4x minus 2 because that's the easier equation to work with. I will substitute the 0 in for where the x is, and then we'll just go through and reduce. So we know 4 times 0 would just give us 0. So since the negative 2 is the only thing left, that means y has to equal negative 2. And so if x equals 0 and y equals negative 2, then the answer to my expression will be listed as the point 0, comma, negative 2. So let's go ahead and look at another example. And this one hopefully will be a little bit easier because we already know the value of y because they just told us that y equals negative 5. So to set this one up, I will take the parabola that I was given, set it equal to negative 5, and then solve. So of course we said that the first step is always to make one side of your equation equal 0. So we'll go ahead and do a plus 5 on both sides. So of course that's going to give me a 0 over here. Negative 3 plus 5 is 2. And then everything else will just carry down. Of course, if I try to factor the x squared minus 2x plus 2, I'm not going to be able to come up with two whole numbers that multiply to 2, but then would add to negative 2. So that tells me I'm going to have to go back and use the quadratic formula. So what we're going to start with is plugging in a, b, and c. So the a is the coefficient of x squared, the b is the coefficient of x, and then c is the constant at the end. So let's go ahead and see what that would look like. So what we'll notice here is that the negative 2 went in for b, the 1 went in for a because there's nothing in front of x squared, and then 2 went in for c because that's the number by itself on the end. So the first thing that I'm going to do is simplify the stuff underneath the square root. So the negative 2 squared will go first. And of course, negative 2 times negative 2 is going to give me 4. Then we'll do all of our multiplying. And we'll multiply the negative 4, the 1, and the 2 to get negative 8. And then we'll subtract the 4 and the 8 to get a negative 4. And then we want to remember back to our previous units where we said that we can't take the square root of a negative number without converting it into an imaginary number. Now, because imaginary numbers don't show up on the graph, when I try to square root that negative number for this system, I'm going to get no solution. So again, it's no solution. because when I plugged my numbers into quadratic formula, I got an imaginary answer which won't show up if I had a graph. So let's go ahead and do one more example. We're going to go ahead and set the two equations equal to each other, just like we had done on the previous problems. We're going to rearrange our equation so that one side is equal to 0. When I'm doing these, I like to have a positive x squared instead of a negative x squared because it makes the factoring easier. So what I'm going to do is take all the stuff on the left and cancel it out. And so when I do that, I will get a 0 here. The x squared doesn't combine with anything on the right, so we will just carry down. If I do minus 2, that gives me a minus 4x. And then 2 minus 7 will give me a negative 5. And so now that I have one side equal to 0, I can try to set it up by factoring. Of course, this time it will factor because I can multiply 5 and 1 to get 5. And then if I make one of them negative, it will add up to negative 4. So we'll go ahead and fill in our box by carrying down the x squared on the top row, the negative 5 on the bottom row. And then, like we said, we're going to split the middle term into minus 5x plus 1x. And then factor. So across the top row, I can factor out an x. First column, same thing. That's where we get our x squared. On the bottom row, since I already have x and x, the only thing that I can put in front is a 1. And then in the top row, if I see the minus 5x and I've already taken the x to the front, we just need the 5 there. So our two factors are x minus 5 and x plus 1. So once we have our factors, we know that the solutions are the x values that make each factor equal to 0. So if I see an x minus 5, then I need a positive 5 to make that factor 0. And then if I see an x plus 1, I need a negative 1 for x to make that 0. And so once I have my values of x, I'll just plug in to get my values of y. So I've plugged in 5 and negative 1 into the equation of the line, and then we'll just go through and simplify. So negative 2 times 5 would give me a negative 10. Negative 10 plus 2 would give me a negative 8. Negative 2 times negative 1 is going to give me a positive 2. And then, of course, 2 plus 2 is going to give me a 4. And so basically, to present our final answer, we're just going to put the x's and y's together. So when x equals 5, y was negative 8, so that'll be my first ordered pair. When x was negative 1, y was equal to 4, so that'll be my second ordered pair. And now that I've got my answers written as points, that's really all we need. That's all I have for this one. I will see you guys next time.